These are basalt stones, and this is a Hauruton drainage channel. What the two have in common is what I want to show today. Let's start at the beginning with the formation of basalt. I am standing here in the factory of Deutsche Basaltfaser GmbH in Sangerhausen in Germany. The basalt we're talking about here today solidified from magma into stone many thousands of years ago. How did that happen? Magma rose to the Earth's surface during a volcanic eruption. It came from at least 40 kilometers below the surface and had a temperature of up to 1,200 degrees. As it cooled, the magma solidified into basalt rock. This has been happening for many geological eras and is still happening today. Basalt is found all around the world, in places where there are active and extinct volcanoes, such as Iceland. Basalt forms spectacular landscapes here. Even on Mercury, Venus, Mars, and on the Moon. Basalt also exists on meteorites. Back to Earth, to Germany to be precise. There is a lot of basalt here too. It is mined, for example, in the Eifel and in the Rhön. Basalt has great properties. One of them can be recognized immediately. Basalt is anthracite to black. And because it is formed on the Earth's surface by rapid cooling and without pressure, it has a fine-grained and stable structure without crystals. This is what makes it so hard and resistant. Another advantage: basalt occurs frequently and is a purely natural product. Strictly speaking, it is a renewable raw material, because it forms with every volcanic eruption. Every year, thousands of times more basalt is formed on the Earth's surface and in our oceans than we can use. The raw material becomes particularly sustainable when mining and processing are close together. Once mined, basalt is used for all kinds of things. We find it in places where the going gets tough. For example, on roads, paths and rails, and in construction. Because it can even withstand the extreme conditions in space, it is also used in lightweight structures for space travel. Wait a minute, a rock in lightweight construction? Yes, it works, because basalt is also in demand as a lightweight raw material. The basalt fiber is flexible and yet enormously resilient. It copes well with tension and pressure, heat and cold, moisture and chemicals. But how is a textile fiber made from a stone? The production of basalt fiber begins with the crushing and cleaning of the raw basalt. Then it's off to the melting furnace. Here the rock is turned into molten basalt or lava. The glowing melt is pressed through nozzles and pulled. Like spaghetti, only much finer to a diameter of 10 to 20 micrometers. This creates fibers that can be bundled and spun, either into a long yarn or into short fibers. It's exactly these basalt fibers we find today in our FASERFIX drainage channels. After decades of proven use in space travel, we now find them in our concrete. Why is that? Because this FASERFIX drainage channel has to withstand heavy traffic, weathering, and chemicals. FASERFIX is a fiber-reinforced concrete that was previously reinforced with plastic fibers. With basalt fibers, this now works more sustainably, because without plastic, production and recycling are significantly more environmentally and climate-friendly. At the same time, the basalt fiber now makes the FASERFIX concrete even more durable and safe. So what began thousands of years ago with a volcanic eruption is now in this drainage channel. Crazy, isn't it? Even if you can't see it with the naked eye. Your contacts at Hauruton will be happy to tell you more.